Okay, so in this video, I will be explaining the process that you need to take into account to train a multilayer perceptron using Keras. So the idea is to explain a little bit about the process that you need to make. It's relatively simple, but I want to get into the detail of what are the functions, the libraries, and the considerations that you need to take into account in order to train a neural network using Keras. So first, well, it's important that we use or we import the Keras library. So to do that, well, we are here importing TensorFlow. Um, and also from TensorFlow, we are importing Keras. Afterwards, one of the reasons that we are using Keras is that we have available different datasets. So for this purpose, we are importing from Keras the dataset called Fashion MNest. This is basically a dataset that has images of different types of clothes. So we want to classify or create a neural network that see the image of a cloth and classify that automatically. So we are saving the information from this dataset into this variable that is called Fashion MNest. And also, we have a method in this dataset that is called load data. And we are using this line of code to separate the training data and the testing data. And here, what I am doing is to basically print the shape of the training data. And well, here you can see that we have 60,000 samples. And these images from the clothes have a size of 28 by 28. That means that we have 28 pixels in the height and the width of the images. And well, also, notice here that I am importing the training data and I'm saving that into a variable that is called x underscore train full. But you will see later that in order to train these neural networks, you need to also have a validation dataset. So to take the validation dataset, well, what we can do is to take the full training data and divide that into a training fold and a validation fold. That's why you can see here in this part of the code that I am taking the X train full dataset and I am dividing that into a validation set and also into a training set. Okay. Here I am using the first 5,000 samples from the X-train underscore fold dataset as a validation set, and the rest of the dataset I am using that for training. And I am doing the same for the labels, no, or for the target variable of this dataset. Here I place the class names of this dataset. We have a t-shirt, a trouser, a pullover, a dress, a coat, sandals, shirt, sneaker, bag, ankle boot. So these are the pictures that we have in this dataset. And we can look into these labels. For example, sample number 0 basically represents a code. I can change this index from the target variable and well, you will see the label, no, that is associated with the second. Well, yeah, that's their sample, no, in the data set. Remember that the indexes here in Python start from 0. So this number 2 is basically sample number 3 from the data set. And here I am importing matplotlib.pgplot in order to plot some of these images. So I have created here a for loop that is basically taking the first 10 samples from the dataset and it is printing those samples as images here in this section. And here you can see that, well, in the previous line of code, I take the dirt sample from the dataset. And here you can see that the dirt sample is indeed a sneaker. No? So this is like a very basic code, only to have like this visualization step of the dataset. But well, the important part of this video is to see how you can create a neural network, no, using Keras. So in order to create a neural network like a multi-layer perceptron, what you need to do is to call this method that is called keras.models.sequential. And basically, this idea of sequential means that we will be stacking in a sequence the layers of our neural network. And well, here you can use this function from that is called sequential that is available in Keras. And this function will receive a list of layers. Here I am defining a list in Python using these brackets. And inside this list, we can generate layers also using the Keras library. So here I am calling keras.layers. And here notice that the first layer that we are defining is a flattened layer that will receive as an input shape um, a matrix that has a form, well, dimensions of 28 by 28. But the reason of using this flattened layer is that we want to convert that image that has a 28 by 28 pixels and convert that into a row vector. So to do that, we are using this flattened layer, and that implies that we will have a column vector that can be used to be fed into a layer in a multi-layer perceptron. This is crucial because multi-layer perceptrons receive vectors. No, they cannot work directly with the two dimensions of the image. So we need to create this one column vector that will contain the pixels from these images. And well, this will lead us to having a column vector of size 784. And we want to use that column vector to feed that into the next layers of the neural network. So to do that, or to define the first layer that will have learnable parameters, we can also use keras.layers.dense. This will create a layer that will have the specific number of neurons that we want. And also we can define the type of activation function that this particular layer will have. So here I am using 300 neurons. Also, I am defining a second layer that will have 100 neurons and also using the same activation function. And finally, we have a final layer that will consist of 10 neurons. But here I am using an activation function that is called the softmax activation function. And here you can see that I am defining 10 neurons. The reason for that is that, well, as you can see here, we have a total of 10 classes or 10 types of clothes in this dataset. So this final layer will need to be consistent with the number of classes that we want to classify. And also I am using as an activation function the softmax. This softmax function turns the output of the neural network into probabilities that will add to 1. Okay, so we are assigning probabilities to each of the outputs of this final layer. So the output with the highest probability will be associated with the class, no, that the input image is belonging to. Okay, this is the estimate that the neural network is given, but we are expressing that estimate into a probability form. Okay, so well, basically you can run this code, and in this way you can define very easily the structure of your multi-layer perceptron. And finally, you can also plot the summary of this neural network that you have already defined. And you will see that you can see a summary, you know, how many neurons that you're using, if it is a dense layer or is a flattened layer, how many weights each of these layer has. You can compute this by yourself. For example, notice here that the output of this neural network of this layer is 784. So if you want to compute how many parameters you will have in the next layer, you can take the output shape, that is 784, and you need to multiply that by the number of neurons that you have defined. And also you add the bias term, that is also the same as the number of neurons that you have. So you can make this operation and you will see that the result is equal to this one, 2035 500 parameters. Okay, and the same applies to all of the layers. No? So you can see that this is a very complex neural network because we have a lot of parameters. And also you can plot a summary of the layers that you have defined. You can see here that we have the flattened and the dense layer number 0, 1, and 2. And also you can get the layers structure by clicking model.layers, and you can get the first layer using this structure. And here is basically a simple code in order to see or evaluate if the layer is dense or not. Also, you can extract the weights and the biases of the neural network using this command. And also, well, as I mentioned before, well, you can define the network, but once you have defined the network, you need to compile that. So one of the crucial things to take into account is that when you are compiling this neural network, you need to define certain things. For example, which optimizer or optimization techniques you will be using in order to train the neural network. Here I have defined the SGD, that refers to a stochastic gradient descent. And also I am using as a loss function the sparse categorical cross entropy. Well, this is useful because we can use this sparse categorical cross entropy when the output refers to integer values. Okay. This is useful because, well, as I mentioned before, we have 9 classes, so we can assign an integer value to all of these classes. Okay. And also you can specify which metric you will be using to train the neural network, no? Which metric you want to monitor when you are training your neural network. So once you have defined what will be the loss function and the optimizer and the metric that you will be analyzing, well, then you can use this function that is called model.fit to train the neural network. You need to define the training data for the X and Y, the number of epochs, and also the validation data. That, remember that in a previous step, we defined this validation data in this section. So that's why I needed to make this partition from the full training data. I need to define a subset that I call train data and also another one that is called validation data. And you can see here that, well, here in Python, we are monitoring the performance of the neural network. Here they are predicting the accuracy, the validation accuracy, the loss and the validation loss across the epochs of that we defined previously. And finally, you can convert that history. No, this we are saving the feeding information in history, and we can plot that history. That is basically the information that we are looking at here, and plot that into a graph. And here you can see that we have the validation, accuracy, and loss of the neural network. Here, only one step that we are making is to convert the history into a data frame in order to plot it here in Python. And, well, also you can use this command that is called test in order to make an estimate of the performance of the neural network. And also there is another command that is called model.predict that can help you to see what is the actual prediction that the neural network is making. So for that purpose, I create a new variable that is called x_new, and I assign to that variable one of the samples of the test set. And well, here I am taking from the test set from sample number 0 to sample number 5. And you can see here that we have the predictions that the model that we have already trained is making. Here you can see that, well, according to the prediction, we'll have this point. Well, this class, the last class of the data set, that is the last element if on our list, will be here. The software is telling us that it is predicting that it will be an ankle-foot. Okay. So this is basically a general overview of how you can um, use this Keras API in order to train a neural network. This is basically a very simple example that you can run in your computer in order to starting to get familiar, with these ideas of neural networks. Later, I will be um, creating other videos in which we can test or see how we can customize the generation of neural networks using this Keras API. But that will be the topic of another video. See you later.